All right. All right, now, how's everybody doing? Right? So when I arrived to teach this, George gave me his book, and I was trying to read his proofs, and I didn't know how to read them, right? But I've gotten better at it. I think I understand. I mean, he had some weird things too, but the things that I didn't like in his proof system, I changed them. And he doesn't like that because we should do it like the forefathers do it, right? The way he does it, he has really basic things. You know, instead of having a big purple table, he has a small purple table. And then he has theorems that if you can do this and this, you can get a proof of your statement, right? But then if I'm deep inside of a proof, it's sort of like there's these applications of these theorems, and it's depending on where you are, it looks different, right? And I just didn't like it. So, right? So what is, right? He wants just the he wants the proof system to have no intuition and just the mechanical symbol exercise of rules, which what we're doing here is still going to be. All right. I'm just throwing intuition on top of it so you can think about both. Right. All right. Now, you probably used this book for 1090. And this is a page cut right out of it. All right. And you were probably taught these various rules, right? The way these rules work is if the top thing is true, then you know, the line of your proof, then you can put the next to the line of your proof. So I call them these remove and add for all. Remove and add exist, right? Other people might call them instantiating or something, right? I don't know. But here, if I know that something is true for every x, then I can plug in my favorite x, right? You can give me Jeff, and I can find out whether it's true for Jeff, right? Similarly on the top right, if C is an arbitrary value and I proved it for C, right, then I can add the Forall in front, right? And then in an existence one, if I prove that something exists, right, then I know that there's some C for which it works, right? Are we good with that? And the last one is if I proved it for some C, then I know there exists a C for which it's true, right? So everybody get these rules? Now, this is straight out of the book. And dude, what's the problem with it? Right? What does arbitrary mean? What does sum mean? You write this little line here, PC, and here you write the line PC. How do I know whether it's arbitrary or whether it's sum? Right? In the middle of my proof, there's one line PC, I don't know what it means. So that's where we're going to add more symbols so that we know what it means. Okay? The book admits that it causes faulty proofs. Well, then don't. Right? All right. So, and I told you already that I understand these formal proofs better when I think about them in terms of sandwiching, right? So how do we do in this here? I want to prove that for all x alpha is true implies that for all x beta is true, right? But, you know, purple table doesn't have any foralls in it. So we have to remove the Forall, play the game, and then put the Forall back in. Right? Everybody see that? So in here, between line 2 and line 19, there are no Foralls. So we're just doing purple table, right? And X here is some arbitrary, right? And in fact, remember I told you, if you wanted to practice the purple table, you could go to that page with all the Foralls and just pull the Foralls exist out, right? Everybody kind of good with that? Right? You want to prove it true for general. Here's how how does it compare? This is what the formal proof does, and what does the game do? The game says, I want to prove a general for all, so I let X be arbitrary. Here it is an arbitrary X. Somehow I prove my statement for that X, and then I generalize, right? This one here might be called instantiation, and this one might be called generalizing. Right, everybody good? Right, what about the proof one? Well, what George has in his book is if you want to prove the exist, you remove the exist, and then you prove the beta, and then you get the exist back, right? And how do we do it? We say, I want to prove I think the general is a typo, right? We want to prove specific X, right? So that's a typo. First time I've used these slides, right? For some specific X, right? So let X be the guy that the oracle is assuring us exists, right? Here the oracle gives us an exist. We go through and we prove it for that guy, and then we know that it exists for some concrete, right? Specific one, so it gets exist. Everybody see these two games? And you see my complaint, right, is that when I'm at this point in George's proof, I didn't know the difference between these lines, right? He's inside of some theorem, right? And so I didn't like it. I like every line to be in a Hilbert proof. Every line means something, right? So all we're going to do is if you have a variable, this is called the free variable, it's sitting there, nobody's quantifying it, just floating around, then that's a free variable, it's a for all. And if I want to remind people that no, it's one specific value, then you plug a little exist on it, right? If anything, you can say, this is the same as George's proof, I'm just notating it a little bit better, right? Are we good with that? Not a big difference. All right. So there we got our two proofs. All right. So we're going to don't worry too much about the nuances of this formal proof, because we're going to have a whole new set of slides that does it, right? I'm just giving you the big picture so that when we do examples, we can actually give you the game, and then we'll throw up the formal proof, and we can see, oh yeah, look at the same, right? Right, so what are our rules? Again, it's removing for all, adding, right? Removing, adding. And when you remove for all, you can, if it's true for any X, you can plug anything you want. You could plug in Jeff. You could plug in father of Jeff, right? You could plug in a free variable A, right? You can plug in anything you want, right? That's how we remove it. How do we add it? If we have alpha X, where X is a free variable, you can throw the for all in front, right? And we just have a little point there that if there's a little exist, or later a little arrow, then you can't bring the for all in, right? Because it's not for all. And then how do you remove epsilons? again, if you have line, there exists the y. Here's what George got more. The other thing, the Forall up here, adding this exists, he probably didn't care too much, right? Here, there exists, so I put the little notation on it, right? But here is the bigger thing, right? Here exists the y, but x is already a free variable, right? So the y that exists depends on the x, right? Remember that? You give me a, right? Because we want to put a for all x here, right? For all x, there is a y. The y depends on the x. So then we add in the little reminder that y is a function of x, right? Everybody kind of good? And then if you've proved alpha is true for anything, right? For Jeff's father's brother, then you know that one exists. Right? Everybody good? That's all we're gonna do, right? And in fact, yeah, no, I don't know.